Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott, and we'd love to have you join us this afternoon. Give us a call if you have a question on your math homework. If you're in Bakersfield, you can call us at 636-4357. If you're in San Luis Obispo, we would love to hear from you. You can also call us. The number's toll-free, 866-636-6284. You can even email us your question. Take a little picture, attach that picture to it, and so we can see it. But you can email us, dothemath@kern.org. You can watch the show online, dothemathonline.net, and of course we have all kinds of social media going on, Facebook, Instagram, Twitter, and YouTube.
And there are 3 days left for the 5th grade calling contest. So we've got today. Next week there will be no live programming due to the Thanksgiving holiday, and then the next week will be the final 2 days for the 5th grade calling contest. So I think right now we've got 4 schools all vying for the top spot right now. So you've got 3 more days to get in on that. Indeed it is. We have a special guest in studio. We'll be heading out to the ROC in a little bit, but first let's take a look at today's Math in the News. So big event over the past weekend, and I thought I saw you maybe out there participating, a little sweat on the brow. Did you take part in the marathon?
It was really hard to watch. Yeah, I definitely was sweating watching all those guys running, yeah.
But the Bakersfield Marathon, the second annual, so they started this thing off last year. It was a pretty nice event, and then they made it even better this year. So a nice event for the Bakersfield area. The Bakersfield Marathon happened, and in the newspaper just yesterday, I wasn't aware of this. It came down to 1/100th of a second.
For the winner?
Right, there it is right
Wow.
there. So down to 1/100th of a second. So you can see, you can see 4 folks here. But right here, this guy with the Bally shirt on and this guy, that's who the race was between. Wow. As far as the 1/100th of a second, because the other folks are in a different category.
Okay.
So somebody would be like, well, why didn't that person get in there or whatever, but a different category right there. But that's pretty darn close,
It's
1/100th of a second. I mean, sometimes it's like, oh, you beat them by a second, just a half a step or something like that. But that's how precise the timing is on these things and crossing the line. So I figured, all right, well, a lot of students know about place value as far as after the decimal point. You've got tenths, hundredths, thousandths, and learning that place value in elementary school. But then there are other ways to look at it also when you get into higher grades as far as scientific notation. So we can take a look at that right here. And we can see the scientific notation. If we have a larger number, we can go 1.5 times 10 to the 4th, because a lot of students are getting used to 1.5 times 10, where they're multiplying decimals and have to move the decimal point. Right. But you can simply see that with the exponent, that will tell you how many places you need to move the decimal point. And if it is a positive one, you're going to move the decimal to the right. And if you're going to make a smaller number, or show how to write it in a different notation, because the number will remain the same, it's just how you write it. And you will have a negative number, and we've got some examples here. Now, Sith, have you worked with numbers like this yet?
No, not yet.
Not yet. So if I had 2.13 times 10, you'd be cool with that?
Yes.
And do you have an idea now what's going on?
Yes.
So explain to me what you see here and what you think is going on and why it's happening.
For the 10 to the 3rd power, you gotta do the regular thing for it. So multiply 10 3 times, so 10 times 10 times 10.
Okay.
And then you're going to multiply that by 2.13.
Right, so you could do that, right? So you'd have 1,000,
Yes.
right, times 2.13. Or, remember, so how many to the exponent here? 3,
Yes.
right? So we just go 1, 2, and then move it one more spot, right?
Yes.
So that's the whole deal with the exponents and the scientific notation. So while you're here, because you haven't worked with these yet, why don't you let everybody know where you go to school and what grade you are in?
I go to Berkshire Elementary, and I am in 6th grade.
6th grade going pretty well?
Yes.
How long have you been at Berkshire?
I've been there since kindergarten.
So you've a lifelong Berkshire learner, huh?
Yes.
All right, well, you know what? We'll talk to you a little bit more about that in just a moment, but now you can see the difference between the positive and negative exponents as far as scientific notation, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays. As I said, next week, due to the Thanksgiving break, there will be no live programming. I'm sure you'll still be able to see Do the Math with some of the current programs that will be shown on those days, but there will be no live programming. So, 6th grade is going pretty well so far.
Yes.
And you've been at Berkshire since you started school.
Yes.
What is the one thing you most look forward to next year when you go to junior high?
Being able to play in marching band that they have at
there you
Stone
go.
Creek.
All right, so you're in band right now?
Yes.
And what instrument do you have?
Mallets.
All right. Well, you know what? That's kind of hard when you're in marching band with those, right? My daughter was doing those, and it, you know, you got a big old strap on you. And so you ready for that?
Yep.
All right, cool. Well, you know what? I'm sure you're going to have a lot of fun over there.
Yep.
But until we go out to the ROC, I'm going to have you go over to the board, and we're going to work on a problem.
Okay.
All right? So here's a problem I know that you've been working on in class. So let's go ahead and try this one out. So we're going to have 66. So start way over on the left. So 66 equals 4, and then open parentheses, 2x minus 3. Close parentheses, plus 2, open parentheses, x plus 4. And if you would be so kind as to close the parentheses and then explain to Scott how you're going to solve that problem.
Wow, we got a lot going on here.
Yes. So the first thing is you're going to multiply the numbers outside the parenthesis to the numbers inside.
Okay.
So you're going to do 4 times 2x, which will, if you do 4 times 2 is 8, and then you're going to move the x down.
Good.
And sorry, just add that since the 66 doesn't have anything to be multiplied.
Right.
And then you do the 4 times negative 3, and since one's a positive and one's a negative, it's going to be a negative. So 4 times 3 is then 12. You're then going to move on to the other parenthesis. So you have positive 2 times x, which is positive 2x. And then you have positive 2 times positive 4, which is positive 8.
Good. Now you said something that I thought was really interesting, and I appreciated the fact that you said it, but you didn't write it down. So let's go back to the beginning, right? You have 4 times 2x is 8x. That was great. What was the next thing you did after that?
4 times 2x is 8x. You then multiply 4 times 3.
Right.
Oh,
And then what is the sign on that? You told me that one's positive and one's negative.
yes. For the 4 it's positive, and then 3 it's negative.
Right. So the 4 times 3 is 12.
Yes.
So what's going to be the sign on the 12?
Negative 12.
There we go. We got to put that in there because every little term in there has to have a sign, right?
Yes.
Nice job. What's next?
We're going to combine like terms, so 8x and 2x,
Now, how come you can't put the 8 together with the 12?
because the 8 has an x. So technically you can't do something that doesn't have one with something. It's like
Right.
comparing
It's like
apples to
8
oranges.
xylophones and 2 xylophones, right? Got to put all those together.
Yeah.
All right, let's see what we got.
So 8x plus 2x, since they're both positive, is going to be 10x.
Good.
And then negative 12 and positive 8, since 12 minus 8 is 4, and since 12 is the bigger number, it's going to be negative 4.
Good for you. I like that. And then 66 just still hanging out over there, huh?
Yes.
All right. I'm going to have you go down just a little bit so you got some more room. What's next?
You're then going to make all the x's on one side. So
Okay.
that means getting rid of the negative 4. So you're going to have positive 4, and these just, well, cancel each other out. You're then
And
gonna,
you can just do that? You can just add 4?
yes. Well, you need to add 4 to the other side also.
Oh, I like what you said there. So if you do something to one side, no matter
have-
what you do,
You have to do it
got to
to
do it
the
to
other.
the other side. Yep.
So you're
Okay.
then gonna add 4 to this, which will get you 70.
All right.
Is it okay if you can
Sure.
start
Oh,
them?
yeah. We'll give you some more room. No problem. So what's left on the right-hand side?
10x.
Okay.
So it's going to be 70 equals 10x.
Wonderful.
You're then going to divide both of them by 10.
Okay.
So 10,
So whatever you do to one side,
you have to do to
got to
the
do
other.
it to the other side. Good for you.
So 10. So you're then going to have 7 equals x.
Good. Now, Sith, how sure are you that that is the right answer? Are you confident about that?
Yes.
Yeah. Would you bet like $20 that that's right?
I don't have that money, but
Oh,
yes.
but if you did, you'd bet it?
Yes.
All right, you're so confident. I want to see why you're so confident. How could you possibly figure out, before a teacher graded this problem, how could you figure out if that was the right answer?
if you replace the x's with the
Okay, let's
sevens.
go way back up there. You told me at the beginning or at the very end that x equals 7, right?
Yes.
Okay, so can you show me at the beginning of the problem here what you would do to see if x equals 7 is the correct answer?
This is where I have trouble in showing my work.
Ah, well, this is kind of a good experiment then. We definitely want to
Yes.
be practicing that.
So let's see. You're gonna replace the x's with 7s.
Okay, so I'll go do that in red because you told me what to do. So 7 is going to go in place of that x, right?
Yes.
And what about over here? Same thing?
Yes.
Okay. And so you tell me what to write here. You have 2, and then you have a 7 right next to it. Is that 27?
Yes.
That's a tough one, huh?
Yes.
Well, think about this. If you had 2 next to it, what is the sign that you could put in between those two things, 2 and x? Is it a plus, minus, multiply, divide?
Plus.
You could put a plus sign in there, I agree. However, if you have it right next to each other, we want to go ahead and make it a times in there. So if you don't see a sign and a letter and number next to each other, we want to multiply that together. So now you know what to do, right?
Yes.
What's 2 times 7?
14.
Good. And we'll still keep that minus 3 in there, right?
Yes.
Okay, how about over here? What's 7 plus 4?
7 plus 4 is 11.
Good job. Okay, so we still have that and we still have the plus 2.
Yes.
So apparently, according to our work so far, this whole thing is supposed to equal 66. We don't know if it does yet, but we're going to find out, right?
Yeah.
Okay, 14 minus 3?
9.
Try again.
14 minus 3. 11.
11, there you go. So we got 4 times, oops, in parentheses 11. We're getting a little squished in there, but we know what we're doing. What's 2 times 11?
22.
Good. So far, so good. So next is, this is a 4, I promise.
Yes.
4 times 11, what's that?
44.
Okay, so 44. And then we already had this 22. You can finish this up. What do you get?
66.
Hey, that works pretty well, and that's a good thing. Now, what would happen if you got maybe like a 68? What would you do if the number over there didn't end up being the number over here? What would be your first thought?
My first thought is I'm going to check the second line that I made to make sure that I did the signs correctly and that I multiplied.
Kind of like we got that one sign, right? So
Yes.
maybe you could have goofed up a sign.
Yeah.
And the other thing you could also check is you could also see if you goofed up in the checking part. Maybe part of the red part is wrong.
Yeah.
But at least it gives you an idea. Got to go back and fix something before you give a final answer.
Yeah.
Nice job. I think you did excellent work on that problem.
Well done right there. Hey, Sith, too bad you didn't take him up on the 20 note. You could have pushed it to 50 and got it right
That's
there.
right.
Hey, we do have phone tutors available until 5:30 this afternoon. Right now, we'll go out live to visit with Devin and the folks at ROC.
Thanks a lot, Mike. We are live at Kern High School District's Regional Occupational Center. We're going to be exploring the craft of welding and fabrication today and really take a look at what gets made and how math is applied here at the Regional Occupational Center. Joined right now by Assistant Principal Steve Miller. Steve, thanks for having us this afternoon.
Hey, thanks for coming.
Wonderful site. We've been here quite a bit this season. We were here with Kern Schools. We took a look at the robotics program. So tell us a little bit about the welding and fabrication program.
This is one of our shop programs out here, and it's a semester of a welding class where the students learn all the basic welds and techniques, and then the second semester class they go on to a fabrication class where they apply those things they've learned.
So the ability to metal work and then take it into actually constructing something with some really solid materials, the space allows students to really explore a lot of those concepts at just a very fundamental, foundational level before moving on to some deeper construction concepts.
That's correct. Yeah, so those students that do learn the basic skills and that have all the safety that they need, yeah, they go on to the fabrication class and apply those things.
What's the demand for these skills, especially here in Kern County, as far as welders and fabricators?
Well, fabrication, we do have quite a bit of fabrication in town, and I think that's where a lot of our kids get their initial jobs in fabrication, and then they move out into the oil industry or different industries we have here in Bakersfield.
So then the opportunity to get hands-on very early on in a student's education, I mean, that sets you up with a skill set that you can take just about anywhere.
Yeah, we try to do that with as many programs as we can, set up internships, have kids go out and do a job, internship, and so we try to do that with all our programs.
So, Mr. Miller, this all starts right here in this workspace here. We're also joined by Welding 1 instructor Bill Bazell. Bill, thanks for having us this afternoon.
Thank you.
Bill, give us a little bit of an idea of the workspace we've got around us here.
This is where we introduce them to the welding industry, or the different industries where welding can apply. We start them with basic safety, and then we teach them basic oxy-fuel cutting and welding, plasma cutting, gas metal arc welding, flux core arc welding, shielded metal arc welding, otherwise known as stick welding, and gas tungsten, TIG.
So the idea here is that you're taking pretty heavy metals and you're finding ways to work with them, cut them, separate them using extreme heat. So there's a lot of safety procedure that you really have to work through in order to be able to handle such extreme conditions.
Yes, sir. Some of the temperatures we deal with in this shop can exceed the temperatures found at the surface of the sun, greater than 8,000 degrees. So definitely safety is a very foundational part of this curriculum.
So when we talk about the curriculum, and we've had a chance to talk a little bit before we were on the air about the kind of math that gets applied into welding at the onset and the kind of operations and calculations that students have to really become familiar with as they explore welding.
Yes, sir. If you're going to work in the fabrication side of welding, if you're just going to be a basic welder, pipe fitting, you're going to look at trigonometry. On the fabrication side, you're going to work a tape measure all day, and that tape measure is going to throw you math problems all day long. Fractional math problems. Sometimes you need to convert your fraction to a whole number and then back to accomplish your goals. So we try to get them started on the basics here. It applies in our industry.
Now, you were telling us about a problem that you worked on here in class today, actually. You had it over on the board here. If you want, we can go ahead and take a look at this, and it might look very familiar, especially when you're in the 6th or 8th grade range and you're starting to look at components of area. So this is a conversation about dividing a steel plate into smaller squares.
We started with the average plate steel comes in 4 by 8 foot sections. I threw up 1/4 inch thickness. And the first question that we asked was, you have 3 plates that are 4 foot by 8 foot. If I told you you needed to cut 18 inch by 18 inch squares, how many squares can you cut out of 3 sheets? So it's practical math as it applies in the actual work setting.
This is a real problem that welders will have to face. And what's fascinating about something like this are the different entry points you could enter into. You know, we're talking about cutting a square measured by inches out of a plate measured by feet. So what are some of the strategies that you've seen some of your students employ to work with a problem like this?
Strategies, I've seen all kinds, really. There are times where I can follow them because I love to have them come up and do the work on the board so that I can follow along and see what they're doing. I will tell you, there have been times where they're using concepts or math, for lack of better words, math, a process in order to find the solution that I'm lost. I'm trying to follow them going, okay, what are you doing? So one of the things that I commonly tell them is there's more than one way to skin a rabbit. You know, you've got your way, I got mine. But if we are coming to the same answer, we're okay.
we went ahead and posted this on our Facebook feed, so if you want to give yourself a chance to work through this problem and see how you approach it, go ahead and check out our page on Facebook, Do the Math Bakersfield. Bill, thanks for showing us this problem today. I'm just thinking of a lot of different entry points into something like this. You got a great workspace here, and you're doing great work to get kids into a field that needs people, and this is a skill that you could just jump right in on if you have the wherewithal.
Thank you.
So a little bit later on in the program, we're going to move over to the Fabrication Center here at the Regional Occupational Center. Coming at you all afternoon. We'll be right back, and we're going to take a look at how the welding component comes over and joins up with the fabrication. But for now, we're going to send it right back to the studio. Mike, back to you.
All right, thanks for that, Devin. Check in with those guys in a little bit. Hey, we do have phone tutors available until 5:30. Don't forget, we've got 3 more days left on the 5th grade call-in contest that is going on through the end of November. We've got Sith in studio ready to work on another problem.
Yes.
All right, so let's take a look at the problem together, and you can go ahead and start writing up any information on the board that you need to. Okay. All right, so it says Mel had $35 and withdrew some more money from the bank account. He bought a pair of trousers at $34, 2 shirts at $16 a piece,
Good job.
and 2 pairs of shoes, and those were $24 each. And it says after he did all of that, he had $32 left. And the question is, how much money did Mel withdraw from the bank?
Good job. I'm going to fix your 5 here to make sure we know it's a 5. But I think you have all the information there, and this is done like a true mathematician with the information all over the page. So I appreciate the way you've done that. Now we got to go back and organize a little bit, right?
Yes.
So let's make sure we understand what's going on here. He started with 35. I like how you wrote the $sign there, right?
Yes.
And then part of the problem, the only part of the whole problem that you didn't write down, we got to figure out how we're going to write that. It says he took some money out of the bank. So when you take money out of the bank, where does it go? Does it go in your pocket?
Yes.
Yeah, so he has 35 bucks, and then he ends up getting more money to add to that. The question is how much, and how do we represent that?
I'm gonna write a plus and then have,
Yeah, plus a blank. We don't know what it
Yes.
is, right? How can we represent a blank spot or something we don't know in math?
you can use, like in the problem earlier, you can add x, you
Okay.
can make a letter.
Sounds good. Go ahead and put the X up there. We're in the blank spot. I think that's a great idea. And X represents what?
X equals how much money he withdrew.
Right, exactly. So I'm going to put that over here, even though we pretty much know that's how much money in the withdrawal, right?
Yes.
Withdrew. With D-R-E-W. Just so we know what it is. At the very end, we know that's what we're looking for. Okay, so
Yes.
what's going to happen in this problem? Can you kind of tell me a little bit about how you want to go solve it?
Well, the first step that I'm gonna do is figure out all of the numbers that say times 2.
Okay, sounds good.
24 times 2 is 48.
Okay.
So I'm gonna write equals 48.
Yeah, so that's a pretty important number, so we'll circle that one. We're going to use that one. What else?
And then I'm gonna do 16 times 2. And that will equal that'll equal 32. So
Good, that's a pretty important number. What about that 34? You think we're going to use that as well?
yes.
Okay, so we'll use that one also. And what we're going to do with all these numbers. So
Well-
when you have money in your pocket
Yes.
and you go and buy something, what happens to the amount of money in your pocket?
The money will decrease.
It will decrease. I totally agree with you. So he's got some money in his pocket, and then he
Yes.
goes and starts buying stuff, right?
Yes.
On a little shopping spree. So his money is going to start going down. Would you agree?
Yes.
All right, so let's see if we can write ourselves some kind of equation to represent that. Remember at the top we had 35 plus x? So
Yes.
we're going to have to start with that. That's how much money he has to start with, and we'll go ahead and put that in parentheses so we know this is how much money he starts with. Go ahead.
Okay.
And then after that,
You're going to write the numbers. So
we have to start subtracting, right? Because he's going to start buying stuff. So the first thing he bought was $34. We'll put that up there.
Yes.
So minus 34. And what else?
minus 48.
Good.
Is it okay if I can
Yeah, totally.
plus 32?
Oh, so you're thinking that all that stuff's in the same bag, and you're going to bag it all up together and then
Yes.
subtract out the total.
Yes.
It's a great idea. I like it. Now, at the very end of the problem, at the end of his shopping spree, how much money does he have left?
He has $32.
So do we have an equal sign in this problem?
Yes.
Where does that go? Oh, right there. Oh, so at the very end, his pocket equals 32 bucks.
Yes.
And again, what's the goal of our problem? What are we shooting for?
To figure out how much money he withdrew.
That's exactly right. So, where do you want to start, Seth? This is a great problem. I think we're all set up, but we got to be able to have a next step, right, before you start moving things around?
Yes.
So what are you going to do?
I am going to the way that I would most likely do it is I'm going to do 35 minus 34 since we already know the answer to that, which is 1. And it seems pretty easy.
I like that idea. There's absolutely nothing wrong with that. I also want you to think about this, right? You did a really interesting thing, and you put all those numbers in parentheses. That was a great idea. When you put all those numbers in parentheses, sometimes we like to do those things first because, like, hey, all this stuff's in the same group.
Yes.
So what you've done is okay, but I also wanted to let you know you could do it a different way and put all those things in the same bag together. But let's go ahead and do that 35 minus 34. I think that's an interesting way to do it. I like how you're thinking there.
So the 35 minus 34, so basically you got to get rid of the 34 now. So you're going to have 1 plus x
Oh, interesting. All right.
minus 48 plus 32.
Wow.
Now I'm going to add 48 plus 32.
Oh, I see where you're going with this. Okay, what about that 32 on the other side?
Oh,
Is that still there?
yes.
Okay. So I just want to make sure we didn't lose it. All right, so let's see if we can get us some more. I'll bring you back up here. There you go.
So the 48 plus 32, that'll equal 0, 1, 7, that'll equal 80.
Okay.
So you'll have 1 plus x minus 4 minus, whoops, minus 80
Okay. Equals what?
equals 32.
Gotcha. And what was this number over here? What was all this stuff?
1.
1. Oh, that was a 1. Okay.
Yeah, whoops.
So we'll make that into a 1. And then what was this?
Plus.
Oh, that was a plus sign. Okay.
Yes.
So we'll fix that up. That's all right. Just want to make sure we know what we're doing there. Okay,
Yes.
what's next? This is interesting. We've gotten into a little smaller problem now.
Yes. So right now we have 1 left over from the 35,
Right.
and then we have the x. So right now we know that we're gonna need another 79 just to reach the 80.
Wow. Okay.
So I'm going to get rid of the, sorry. So I'm just going to first of all, I'm going to do the 79 plus. I'm trying to word this in a
Yeah,
way.
it's an interesting way you're wording it too, because I can tell your brain's going, but we got to make sure we're mathematically sound here, right? Okay, so
Yes.
here's what we're going to do. What I'd like you to do is write this problem again with no parentheses.
Okay.
Just go ahead and write all the stuff you have left. You can do it right underneath. And then the last problem that you wrote, I thought you made a really good point. We want to combine like terms, right?
Yes.
So you have this x here. Are there any other x's in the problem?
No.
So you can't put that together. What about the numbers?
You can use the numbers, so you're gonna have one measly little 1, and then you're gonna have 79.
Gotcha. So tell me why you subtracted.
79, since that was the number left over from 35. So you have
Right, but
$1.
here in this situation, you have an 80 and you have a
Yes.
1, right?
Yes.
Tell me why you subtracted those numbers.
Because the 80 is how much it costs up there, and the 1 is how much money you actually have.
Oh, I see. Okay, gotcha. Now, at the end of this part of the problem, is that 79 a positive 79 or is it a negative 79?
Negative 79.
Why?
Because, well, first off, the 80 is negative and the 1 is positive.
There we go. I like what you did there. Okay, and I'm going to go ahead and put this x in here for you so we don't forget about that part,
Okay.
right? What about the other side of the problem? What's left on the other side?
The other side is now figuring out 79
We have an equal sign here, though, right?
Yes.
What's over there on the right?
32.
Good job. Okay, so it looks like we have one step left, right?
Yes.
Okay, go for it.
So the way that I'm going to do it right now, since the x can automatically equal 79, from what we know. So I'm going to do 79 plus 30. 79 plus 30.
What you're saying is wonderful. I like the way you're saying that. Now, you told me in the last one that when we had a multiplication problem, we did
Yes.
the opposite and did division, right?
Yes.
So in this problem, what does this say? This says x minus
Yes.
79.
Yes.
So what's the opposite of minus?
Plus.
Plus. So I'm going to do it over here, and you do it over there. Because you told me in the last problem you have to do it on both sides, right? You have to. Exactly. Well done. That's what it was, right? So you were saying that in your head, but we want to make sure that we understand exactly where that's coming from.
Yes. And then this equals 111.
What equals 111?
How much he spent not counting the 35.
Ah, gotcha. So remember this part right here? We want to
Yes.
make sure we have an x equals. Okay, this is your favorite part. Can we check it?
Yes.
That's the answer we're looking for. Okay, so if we go all the way back to the beginning, apparently, according to your work, the answer is 111. Where do we put that?
Let's see.
Well, maybe look at
Where is it?
our initial equation right here.
Okay, so right here,
Yeah. So where does the 11 go?
the 11 will go right.
Gotcha. So here's the deal. I'll make you a deal. If you can do me a favor, add all those numbers together, okay? I'll add all these numbers together,
Okay.
and then we'll see if we can come up with the 32 over there.
Okay.
What was the final answer?
The final answer was 111.
Gotcha. So I'll add a 1 right there just to make sure.
Okay.
So I have 111 and 35.
48, 32.
Good. There you go.
Add 0 and 1, and then this will equal 80. And now I'm going to add the 32 to it.
Okay.
So, I mean 34. Whoops. 34.
Good.
This will equal 4, that'll equal 114.
Gotcha. So this says that my total, 146,
Yes.
minus 114, which is what you got. What is this answer supposed to be?
32.
You're psychic. You know it already before without doing it? Are you sure it's going to be 32? Let's find out. If it is, we are in luck, which means we have checked the answer. 6 minus 4, 2.
2, 4 minus
4 minus
1,
1,
3,
3,
1 minus 1, cancel each other out.
all gone.
0.
Nice job. So that's a great way to check it. And now you know the amount of money that you took out of the bank
Yes.
is?
32 is $111.
That's right there. Good job. Well done.
There you go, nicely done. And important to remember what the question was looking for, because there's a lot of numbers up there.
A lot of numbers.
Was it the 35, the 32 on the other side, or what was it? And it was the $111. Hey, we do have phone tutors available until 5:30. We'll be back with more right after this. Today we're at Browning Road Elementary School, and today we're here to We're at Browning Road Elementary School with Samuel. You ready to go?
Yeah?
All right. Do you have any idea what that means?
No.
Okay. It has something to do with math, right?
Yeah.
Okay. So LCM is the least common multiple. So we're looking for multiples of numbers, and we're looking for the lowest one in all three of these. Okay?
Okay.
So we're going to be looking for multiples. So 4 times 1 is what?
4 times 1 is 4.
Okay, so write a 4. 4 times 2.
4 times 2 is 8.
Okay. There you go with the commas. Keep going.
So is 8. 4 times 3 is 12. 4 times 4
Right?
is 16.
Good.
4 times 5 is 20.
Okay. So let's go ahead and stop right there. Okay, let's start doing some 5s.
Oh, no.
Where are you getting these numbers from?
My head.
Oh, okay. Well, I need you to say them, though, so I know what you're doing.
Oh, sorry. 5 times
So where do you get this? 5 times?
2. 5 times 3. 5 times 4. 5 times 5.
Okay. So we'll just do 5 of them each. Okay, so let's go ahead and do the 8s now.
8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5.
Okay, so we have 5 of each, okay? So we're looking for the lowest one in all of these. Is there a number that is in all 3 of these rows?
No.
No. Is there anything in at least 2 of them?
Yeah, 20.
The 20, okay? So that might be something that we can start focusing on, okay? But we've gone past 20 here, and we got all the way up to 40. So we need to find something that will be in here, that will be in here also,
Okay.
okay? So how about if we go with a couple more there?
What am I at? 4 times 6 is 24. Boom. 8 times 3 equals 4 times 6.
Okay, but do we have a 24 here?
Oh, no.
So 24 won't work. We almost, that was a good try, right? All right, so keep on going.
4 times 7? 28. 4 times 8?
Right?
32. 4 times
We have a
9.
32 and a 32, don't we?
But no 32
No
right
32
here.
there, right? So we have to keep on going, right?
32 and then 4 times 6. I mean 4 times 9.
Right?
37, I believe.
Almost. You said the 6.
Oh, it's 36.
There you go.
6.
4 times 10 is where you're at.
40.
Okay.
4 times 11, 44.
All right, so let's pause there for a moment and assess what we've got. All right? So we know we had 2 20s. We have 2 32s,
And 2 24s.
2 24s,
Oh, 2 16s.
2 16s. We have a lot of 2s. All right, we have a lot of pairs.
Oh,
What about
2
4?
32s.
2 32s,
2 40s.
2 40s. All right, so let's work on this one. What do you think? Can you see the answer right now? We know that we have a 20, right? 16 and 16 isn't going to work because there's no 16 here. All right, 8 and 8, because we're trying to get a low number, right? And that'll work.
Oh,
But right now we don't have anything.
I feel like right here, the 40. Because if it keeps going down by 5s, then it would reach to 40.
Okay, so let's go ahead and put the 40 there.
Right
We
here?
can just go like this. We'll go dot, 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 and we'll put you 40. So, do we finally have an answer, do you think?
Yeah.
What is it?
Oh, 40.
All right. So go ahead and circle each of the 40 so we make sure that we don't have anything lower than those. So take a look at it once again. Are there any other multiples that are going to be lower than 40?
No.
That's it. So here's how you say this. You say the least common multiple of 4, 5, and 8
Is 40.
All right. So go ahead and tell me one more time.
The least common multiple of 4, 5, and 8 is 40.
Samuel, nice work, dude. And a big thank you to all of the staff and students at Browning Road School. We had a wonderful time out there. We do have phone tutors available until 5:30 this afternoon. No live programming next week due to Thanksgiving, and only a few days left for the 5th grade call-in contest. We have Sith in studios, been doing some fantastic work. We'll give you a little bit of a break right now while we go back out live to visit with Devin at ROC.
Hey, thanks a lot, Mike. Back here live at Kern High School District's Regional Occupational Center, joined right now by welding and fabrication instructor Scott Trimble. Scott, thanks for having us in the Fabrication Center. Tell us a little bit about the space we've got today.
Well, thank you for having me on. As you guys saw earlier, that was the welding one side where the students come in, most of the students come in not knowing anything about welding. So they come in, they learn the basics starting from the ground up. Safety, oxy-fuel safety, then general welding practices. And over there, they do a little bit of building, but over there, it's primarily learning how to weld, how to set the machines up, what different welding processes are, what they apply to, and how to use them. Once they complete their semester over there, Then they move over for a semester on my side, which is a little bit more advanced welding and fabrication. Now, the main difference there, fabrication is on this side, they actually build stuff. They complete projects, stuff that we do here for the school, and also the students can build projects for themselves. As you can see, we have a multitude of projects going on here, so it's something where they actually learn the welding processes plus fabrication, and come with building, that's where they need to start applying math. Even though they don't know they're generally doing it, a lot of it is math-based, reading a tape measure, figuring out areas, figuring out what material they need to order.
One of the parts of that we were talking about with a project that your team is working on right now is scaling. In fact, there's a device over here, a plasma cutter, that illustrates that pretty nicely. So kind of guide us through the plasma cutter here. And we have a plate design that we're working with through the U.S. Marine Corps.
Yes, this is our Lincoln Electric Torchmate 4800 table. This is a fairly new machine to our school here. It is a great tool to have, a great tool for the students to learn on. And as you see over here on the computer screen, we have a drawing, and we could scale in to see it. And also, we could scale this to different sizes. When we scale out the black outline, that's a 4 foot by 8 foot sheet of material. Now, we could change the scaling on this just by coming up here and entering different numbers. So once we get the basic design in, we could scale that from something 0 all the way up to a full 4 by 8 sheet of material.
And we were talking about a 4 by 8 by 1/4 inch steel plate in with Bill Bazell in the welding room, and this is pretty emblematic of that kind of plate, of what that really looks like.
Yes, this is a 4 foot by 8 foot sheet of 1/8 inch thick material, so it's about half the thickness of 1/4 inch, but it's still 4 by 8 sheet. And in here, you'll notice we have a bunch of designs cut out. This in here, you could barely make it out, but that's a Camp Hamilton cutout, and that's going to be going on one of the projects that we're going to see here in a little bit. And this is the finished product. This is how it comes off of the plasma cutting machine. As you can see, it cuts out pretty detailed, not super detailed, but it does a very good job on it. So this is something that we cut out here that we get to use. We use it for in-class projects, as well as students to take stuff home, as well as projects that people come in from outside the school district that they would like us to work on. It's a good opportunity for students to work with people that come from outside the school that, hey, we'd like you guys to build a project. Can you help us with that? And that's what this project is here that we're going to see here in a little bit.
And it lets you really scale in as far as any kind of design. If you have a vision for it, the plasma cutter will be able to punch that out, and no space is wasted. I mean, I could see a few dozen, maybe a couple of dozen of those printed off just on one sheet.
Yeah, and that's one of the things that we teach here is inventory control. Project management is, if we're doing a job for somebody, I teach them, if you're working for an employer and there is wasted material turns into wasted money. Wasted money turns into the employer, hey, we need to do something to kind of fix this. So it teaches them, they got to use the math on how could I nest stuff different? How could we get the most out of our material to maximize the dollar? So a lot of that goes into project management and project design on how can we get the most out of what we have to save the customer money and get the best end product.
So we were talking about this project through Camp Hamilton and the U.S. Marine Corps that your team's been working on. This isn't just some sort of, real quick moonlight project. This is a pretty significant order.
Correct. Yes, it started out just with one bench. Actually, one of our teachers here at ROC, our law enforcement instructor, he is part of Camp Hamilton, and he came up with an idea. And so myself and the students said, okay, we took his vision and ran with it. We said, okay, this is what you want. They would like a bench. He wanted it for a Veterans Day service at Camp Hamilton, and we got it done. We got it done on very short notice, which that helps out also because we made the customer happy and we had a great end result. And something that started out as one project turned into, we have an order for 5 more, and they're talking about an order for another 5 more after that. So the students are kind of seeing, hey, they did a good job, and now customers want, so that's developing a good customer base. And that goes back to, a lot of it's math related. It goes back to how long are we going to cut the material? We want to make all the benches the same. That way one's not short, one's not larger, make sure it's not crooked. We want everything to look square, aesthetically pleasing, and also utilize the best material management that we can.
I wanted to bring in Daniel here, the 12th grader here at the Regional Occupational Center. Daniel, thanks for joining us. Wonderful work we've taken place here with this bench. Tell us a little bit about some of the work that you've been able to employ with this object today.
Well, Trimble just, he told me how they wanted it, what measurements they wanted it, and he gave me a blueprint that showed the cuts I have to do right here. So there's a 10 degree right here, a 5 degree right here, 5's right here. These are also 5 degrees. 5's on these ends, and 5's on those ends, and then the rest is 90 degrees.
So those add up pretty quickly, and you can see a pretty significant difference between a 5-degree bend and a 10-degree bend.
Yes.
When you're starting to learn about angles, they don't really seem like there's too big of a difference because you're really only working with them with a tiny little protractor on a piece of paper. When you see it out on this scale, I mean, now you can see the difference in double the angle.
Yes, you can. So these are all 5s right here, but when you bump it up to the 10, it's a lot.
You can see it reclines a little bit more. And so that kind of precision to be able to scale and recreate over the course of multiples of the same object, that you can tell that there's some consistency built in. Daniel, wonderful work so far.
Thank you.
When we come back a little bit later on in the program, we're going to really get hot and heavy with the welding aspect of it. I understand that I need to get myself prepped and ready to go for that. So until then, we're going to send it right back to the studio. Mike, take it away.
All right, thanks for that, Devin. Great work out there at the ROC. All right, we've got Sith in studio, and we've got a fantastic problem for you to work on right now. So you've had an opportunity to take a look at the format.
Yes.
So we have 3 different fractions, and all of those fractions will come out to equal 0. So you can either add or subtract the fractions, however you like. You can use the numbers 1 through 6, and every one of them can only be used once.
Yes.
So why don't you go ahead and explain to us your process of how you would like to solve this problem.
Okay. So the way that I'm going to do this is I'm going to have 2, 4, and 6, since they're all multiples, as a denominator. So I'm going to, so if you don't mind, write 6, 4, 2, and leave that there so that I know that the denominators.
Okay, so we've used these ones right here.
Yes.
And tell me again why you chose those ones?
I've chose them because they're all multiples of 2, which makes it a lot easier in subtracting, and it also eliminates the possibility that I messed up.
Oh, because you can
Since-
have a pretty easy common denominator there,
Yes.
right? Okay. By the way, can you tell me, just by looking at those, what is the least common denominator for 2, 4, and 6?
The least common denominator,
Yeah. If you were going to change them all to the same denominator, what would it be?
I would have changed it to 6.
6 would work, yeah. For 2 and 6, that would work great. But 4
Oh, whoops.
doesn't go into 6, huh?
I would have do it to 12.
12, gotcha. So if you had to change them all, they'd be 12 on the bottom.
Yes.
And that's a pretty easy one to do because the other ones are odd. All right, so I like your thinking so far. So you got those ones on the bottom, and
Yes.
how in the world do you figure out where the other numbers go on the top?
Well, for the other numbers, I am kind of going to do a guessing check.
Okay.
So I'll do 5/6
Uh-huh.
cents, and then let's see. I'll do the 3/4,
Okay,
and then 1/2.
gotcha.
And I'm going to try and figure out the way for subtracting it.
Okay.
So 5/6 minus 3/4.
Well, let's start at the beginning. You said it's 1/2 minus 3/4, right?
Yes.
So we're already in the negatives.
Yeah.
And then you're going to subtract some more, and we're in the negatives even more.
Yes.
So I'm thinking that these might be the right numbers, but we're probably going to have to change the signs.
Yes.
Okay, so what are you going to change the signs to? Oh, do a plus there. Oh, both of them plus, all right. So again, we don't have to do any numbers, but we can think about this a little bit. Oh, you want to keep that minus?
Yes.
So this one, if we subtract these two, we're going to be in the negative. This
Yes.
one's going to bring us back to the positive.
Yes.
Right? So at least we know we're not going to be a big negative number. But how close do you think that is to 0?
1/2 plus 3/4. That is
Are you adding them together or subtracting?
subtracting. Sorry. So 1/2 minus 3/4 is 1. Negative 1/4.
That's it, yeah, negative 1/4. Now, is negative 1/4 the exact same fraction as 5/6? Because in order to get a 0, we got to get them to cancel out.
Yes.
So that didn't work out very well either, right?
So I'm
we're
going
not
to
a
give you
0.
boys a clue here.
Okay.
I like how you were subtracting. So we'll subtract both fractions.
Yes.
Okay.
We're going to start with 5/6.
Oh,
Yes.
so you had the
All
right
right, so
number.
let's make 5/6 all the way on the left. We're going to subtract both,
Yes.
Okay, so put your subtraction signs in between there.
and you boys have 2.5 minutes.
We can do it.
Let's see. 5/6.
Now, are you feeling confident about those other numbers that you have there, 3/4 and 1/2?
No.
Oh, you don't like those either, huh?
Yes.
All right, so where are you going to flip it around to?
I think I'm gonna do 1/4. Sorry. I think I'm going to. I'm trying to word this. I'm gonna do 1.
Maybe don't be so committed to having the 2, 4, and 6 on bottom.
Ah.
Okay.
The 4 is a good option.
Oh, yeah, sorry. 1/4. So 5/6 minus 1/4, and
So
that.
we know we're going to start with 5, 6, right?
Yes.
So whatever's happening in this area right here, here's my thought. Whatever's happening in there, this has got to be 5, 6. Because 5, 6 minus that, it's got to be 0. So this has to be the
Yes.
same value as this one. Can we use those other numbers to make that into 5, 6?
5, 6, let's see. 4 and 2, I'm going to do. So we still have 3 and 1 that we can use.
We do, you're right.
So let's see.
I'd like you to get rid of the 2.
Okay.
They can't stay there. That's your clue.
Okay. So let's see. We can do.
The only other number you have is a 3 and a 1, right?
Yes.
So if you make it over 1, it's going to be that number. So you don't want that. So instead of a 1, your best bet would be a
3.
3. So let's make 3 the next denominator you have.
There you go.
All right.
Good.
Okay.
Now again, this thing is going to be 5, 6, right?
Final
Yes.
minute, boys.
Okay.
Okay, let's see. If you do 2/3. So 2/3, that'll equal 4/6.
Got a lot to think about, huh?
Yes.
And 1/4, that's going to give us a negative. What if we add them together?
Well, remember, you don't want to add.
Let's see. 2/4, that's 3/6 minus 2/3 equals 0.
Wow.
Now, you
All
did
right.
that in your head pretty quick. There were some students going, what's going on here?
Yes, yes. Okay. So let's see. 5, 6 minus 2/4. We know 2/4 is a half.
Okay, 2/4 is a half.
So 2/4 is then gonna be. So let's see.
So I'll just write it up here. This is really like a half.
Yes. And is it okay if I write something?
Mm-hmm, sure.
This and then I'm just gonna.
Oh, I like that. There you go. So
Now the
5
comma.
minus 3 minus 2,
Equals
that's
5.
where you get your 0.
Yes.
Wow, I like how you thought yourself through that. Nice job. Well done.
There you go. Well done on that, Sith. All right, we're going to have an opportunity one more time to go out the ROC with Devin.
Hey, thanks a lot, Mike. Back here live at Kern High School District's Regional Occupational Center with welding and fabrication instructor Scott Trimble. We're wrapping things up here in the fabrication room. We were talking with Daniel before the last break. He's continuing to work on some of the work on this bench, and we had a conversation about contraction of metals and how you have to take that into account when welding.
All right, when you're welding, we're using an extreme amount of heat. When metal gets hot, it expands. You're expanding the molecules in the metal. So naturally, you're going to have expansion and contraction. Expansion as it expands, contractions when it cools down, it shrinks. Now, one of the important parts of that, as we look at the project that Daniel's working on, we have a couple of tack welds. Now, these 2 initial tack welds, they're there to hold the piece in place until he could attach a couple more tack welds. Now, it's very important to have tack welds on there because if not, if we just started welding at one end, the tacked part is going to start moving around, and that could cause a fitment issue with the pieces as we continue to build it. They could not fit right, they could have too much space, not enough space, and the piece could not fit, and that could ruin a project. So Daniel's going to give us a little demonstration here. He's going to put a couple more tack welds onto the piece before it starts, before he welds it.
And so this is a matter, and you know, you notice the mask as far as making sure that you can see the cuts clearly, as well as protecting yourself. We're going to go ahead and put a filter over the camera as well. But, I mean, the visual of being able to see clearly once you do make that weld is very important, and so the right material for the right job is crucial. And so that has a dual effect. You know, one of the things I noticed as I was observing that is that you can see it melt together as it cools, in addition to just when the initial weld takes place.
Yeah, you could see it. As the weld happens, the material in here, the weld is about 5,500 degrees. It almost instantly heats up the metal past its melting point. As it deposits metal in, it welds it together, joins with filler material that comes out of the MIG gun that he's using, and it starts to form the pieces together, starting to form a near unbreakable bond. If it's welded properly, which Daniel's doing right now, it'll be extremely strong. And the weld, in this case, will not fail. If it ever got to the point of its yield strength, the material around it will fail before the weld will.
Daniel, how many of these did you have to do before you felt more and more comfortable with this? Because this seems like a very terrifying prospect for the average person to deal with thousands of degrees in your hands.
Well, after the first bench, I went through a couple problems I had, but once I got working on the second, this is the third one, I ironed out a lot of the problems I had, so now it's starting to become really easy. So for all the other benches to come, I'll be able to knock them out faster and better.
It's remarkable to hear you say that after the first time you kept going into it, it became more and more comfortable to deal with. That's incredible for me to hear. Just even with the extreme temperatures, how comfortable we grow as people.
And that's one of the things we teach here, not just how to weld and build things, but also about problem solving. They call it soft skills, employability skills, how to help the students, whether they're in the welding industry or not, whatever they do, we're trying to teach them how to be good employees and good people in life, how to solve problems on their own, how to be forward thinkers, and how to get things done.
We also wanted to check in with Josh here, who's got some work on the seat weld as well. Tell us a little bit about what you're working on here.
This is my 7018 structural steel plate test. I'm just running it on a 22-degree bevel on both of these, so it makes it a 45-degree angle in the middle. And I have to run about 5 or 6 passes to get my weld out on these 2 flat plates.
So Josh mentioned something really interesting. The fact that they were 22 degrees, but was going to end up in the 45-degree angle. So, you know, when I think 22 and 22, that gets me to 44. How do we compensate for that extra 1?
It's actually, they're cut to 22.5 degrees per bevel.
And a half. There
yeah,
we go.
22.5 degrees. But the American Welding Society, you get a variance of about a degree. So it's not extreme, but it's, when you're looking at here, 22.5 degrees, that's pretty critical as far as the bend. Now what that does, if there's not enough bevel in there, you'll have a hard time filling up the weld. If the bevel's too far open, you'll have to run a lot more weld passes, and the more weld passes, the bigger chance you have for impurities, slag inclusion, porosity. So what Josh is gonna do here is he just made the first weld pass, he cleaned it up, he's gonna run a second weld pass. After he does that, after he gets happy with how the welds turned out, once it gets to the specification that's listed on the D1.1S certification specification. After that, we'll cut it apart, and here in a little bit, we'll show you the strips that get destructive tested that we do right here in the shop that will actually certify these young men and women for certified welders in their industry.
And this isn't just necessarily for high school students. Josh is coming to us postgraduate, and so this is a great opportunity for anybody, if you're interested in exploring the welding field, to come on down to the Regional Occupational Center, check out the program. Josh is going to work on that right now, and as he does so, I want to go ahead and again thank the folks here at Regional Occupational Center, Scott especially, for having us today, and as we do with any time we visit out in the field, award you with our Do the Math tile for an exceptional support of our program.
Thank you very much. It was a pleasure having you guys, and thank you for having me.
As always, Mike, back to you in the studio.
There you go. That's what I was waiting for. Devin and those guys to get busy with a little bit of welding out there. Thanks once again to our friends at the ROC. Phone tutors are available until 5:30. No live programming next week due to Thanksgiving. We'd like to thank Sith for coming in this afternoon, doing some fantastic work. And because of that, he will be receiving 2 tickets to any sporting event at CSUB Athletics. So congratulations on that. So you've got basketball season going on, wrestling, baseball's coming up, swimming, and all sorts of things. So thanks for that. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.